Hello everyone. Before we start setting up motor parameters and programming various functions on the drive, I want to demonstrate 2-wire control and 3-wire control. It's important to understand how those modes operate with drives. That way you can determine what type of control setup you're going to use with your application. I have a control cabinet with an ATV12 drive installed in it. It's a 120 volt input unit. And on the cabinet we have a disconnect switch on the side. I'm going to energize the cabinet. You'll notice that there's a red light on this emergency stop button. That stop button is in series with this green start button and a master control relay. If I push the green button, I energize the master control relay. So when you see me de-energize the power, and then when I re-energize, when I have to push that button, I'm setting the master control relay. It's an extra safety function that we can use with drives. For example, if somebody tries to open the cabinet without locking it out, you'll notice something. There's a limit switch right here. It's in series with the stop button also. So when I open the cabinet, contactor drops out, or the master control relay drops out. Also, we have a braking resistor on the back. If it overheats, there's a contact that's in series with that circuit, and it will de-energize. Now, when I close the circuit, notice how it stays off or de-energized. I have to reset it by pushing the on button again. So now I'm going to demonstrate 2-wire control mode. Now, typically 2-wire control mode is factory default when a drive is shipped. And 2-wire control mode can be either operated manually or automatically, and I'll demonstrate. So here I have a selector switch. It's just 2 positions, so it's just off or on. And there's 2 wires to the switch. There's a feed from the control circuit, the plus 24 volts, and then that feeds the switch, and then the other wire connects to the digital or logic input, and when I close the switch, it sends 24 volts to that input, commanding a run. Now what I'll do is I'll energize my mains, and I'll close the switch, and the motor runs. Now this is a fairly straightforward operation. It's a manual operation, so you just turn it on. It could be a pump that you're using to empty out a tank, and then you can turn it off. It has to be supervised. Or it could be a blower that you just turn on and let it run and then turn it off. But we may want to control it automatically. So in the case of a pumping application where you're pumping a tank down, so I'm only using one float, nothing elaborate in this case, what will happen is fluid will come in the tank, turn on the pump. When the pump starts to empty the tank, the float drops, shuts it off. So this is a fully automatic condition using, or mode, fully automatic mode using 2-wire control. Now, there's one important consideration that we need to think about. What if in the middle of the night you're calling for a pump cycle and you have a power failure? And then the power resumes. Do you want it to run? Well, of course you do. In this case, you're pumping a tank down. It could be a septic tank or a municipal catch basin that catches storm water and has to pump it out. So we have to think about that. Now watch what happens. This is the factory default setting for most variable frequency drives. When I shut this main switch off, so I'm simulating a mains failure, I turn it back on, and I push this button. So I've simulated a power failure. It could be in the middle of the night. The drive will not run. Now this is factory default for a typical variable frequency drive. It's called Disregard Run Command on Power Up. It's a little extra safety feature that they install, so it wants to see that input toggled before it runs. Now we don't want that. We want the drive to run. So we have to go in and we have to change that parameter and say if it has a run command on the input, just run. In this case with a pump, or it could be a heating, ventilation, air conditioning or refrigeration application, you want it to run. So I'm going to go in and program this. I will show you how to do this when I demonstrate programming. This is only for operational demonstration. So what I've done is I've programmed it to tell it to run if there is a run command after a power failure. So I'm going to set it to run. All right, so we're calling for a pump cycle. I'm going to de-energize the mains. Let all the power drain in the drive. Re-energize the mains. Set my e-stop. Now you wouldn't have an e-stop on a pump. It's just for demonstration. And notice how it ran? It just ran right back up. Okay? So again, I'll de-energize the mains. Re-energize the mains. And it just automatically runs because the pump is being called by the float switch. This is one of the most important points that you need to learn when you're working with variable frequency drives. Setting up the motor parameters is fairly straightforward, but if you miss a parameter like disregard run command on power up and your application needs to run, it's going to cause you some grief down the road. And that's another reason why it's very, very important to always test your application in this manner to make sure it operates the way you want it to.